let's examine these expressions a little bit more carefully so to gain some insight of what these expressions truly tell us about the physics of this problem. So first of all, I have written exactly the same expressions for voltage and current right here, but I've made two substitutions. The first one is that I expressed my gamma L as a complex number, so magnitude gamma L and phase theta. And also because my load is at z equals 0 and z is negative, I express z as negative L, so basically L is the length away from the load and is basically a positive number. So this is often done so we don't deal with a negative z, but rather we actually have a positive L. So now my expressions are as shown right here. That gives us the total voltage on the line as a function of L and the total current on the line as a function L. So if you go ahead and look at these expressions a little bit more carefully, you will find out a few interesting facts. So the first interesting fact is that the voltage is not constant, and to be a little bit more precise, the voltage is not just a function of time, as it should be, but the voltage magnitude actually is not constant along the transmission line. In fact, it has maxima and minima that are periodically appearing, and you can easily find when the voltage becomes maximum just by looking at the expression we just derived, and essentially when this guy here becomes equal to 1, you will have a maximum, as shown in this expression here, while when this exponential becomes equal to negative 1, you will basically get a magnitude minimum. So that means that periodically you will basically get this voltage maximum, V0 plus magnitude 1 plus magnitude gamma L, and you will also get periodically a minimum voltage. And once again, I want to emphasize that these are voltage magnitude maximum and voltage magnitude minimum. At every single location of the transmission line, of course, you will have the voltage being a function of time and the current being a function of time. But if you check the voltage magnitude at each one of these locations, you will find out that it's actually different.